Well, thanks for hanging in with us. We only have one more talk before lunch, and I don't know about you, Stefan, but I'm kind of feeling like a roast beef sandwich.
Oh yeah, that's a good idea. It'll cost you one LSAT. It's your ticket aboard the internet's money rails.
All right, we have roast beef, Lalu.
Okay, cool. All right, hey, my name is Laulu, or Olaoluwa. Also people call me roast beef in person as well, or in the internet. I'm going to talk about something called LSAT. Maybe asking exactly what's the internet money rails? Internet money rails are basically Bitcoin and Lightning itself, right? We have existing layers or existing rails which are very slow, they're opaque. There's no API docs, and you can't really build on top of it very easily. While we have Lightning now, which basically gives new opportunity to actually redo all these things for the first time ever. And I guess you're asking what the ticket is. As you've seen a little bit, it's kind of like an API, right? So my talk is going to be mostly about how do you actually build a new service on top of Lightning itself. Actually, maybe is actually Lightning native for the first time itself. So this is more about how do you build new API and service on top of Lightning itself, rather than doing maybe point of sale payments or something like that. A little bit more on the back end side of things. Here's a little outline. First, I'll talk about keys and the abstract and exactly what they are and how they're different from other things. Authentication modes, because if I'm going to be using a service, I need to somehow authenticate with the service itself. Macaroons, maybe some of y'all know about this. Something we use in L&D, pretty popular thing as far as finding great authentication. Basically, how APIs work today, and then how I envision them working in the future. And then once we go on that, we get into something called 402, which maybe some people know about that, related to HTTP. And then finally, we get into exactly what an LSAT is, and some things about basically deployment and specification once you see how everything goes along. First, we have keys. So I guess what is this? This is an API key, basically, right? This is basically something you can have. It has a lock. You can give it to your friend. Specifically, it's like a credential. So basically, if you have the key, you have access to the entirety of exactly what it unlocks for you, right? If I have a key, I don't need to ask somebody to use it. I can basically plug it into the door, and then boom, I can use it right there. So one thing is bearer-based. Once again, you actually have it in your hand. You can actually give it to somebody else very easily as well. It can also be delegated. I give my key to my brother, my friends, whatever else. They get access to my house, and they don't need anything else but the key itself. Revocation is possible. So whenever I revoke a key, I can basically change the locks more or less, and at that point, you can't really use it. Obviously, it's kind of a very involved process where I can basically do this rotation and validate all of the API keys that have these actual physical keys without any interaction between any of the users. And so manual rotation is possible. Also, it's kind of decentralized-ish. You can take a key and actually go and copy it somewhere to a locksmith or whatever else and give it to them and hand it to anyone else. And that's pretty cool part about it as well. Also, that's kind of fine-grained access. You can imagine maybe I have a front door and a back door and a side door. I can give you keys to each one of them. You can even say maybe I have some time locked doors as well. Maybe it only works between a particular time of the day. And then finally, we also have a possibility of master key. So I can basically have one key that works for every other key as well, and it's kind of a cool concept along with it as well. So now we go to another type of key. Here's another key, which is once again, an API key, maybe something you're a little bit more familiar with. This is basically more or less like a username. Maybe it's a base 58 or base 64 actual key. But it's a little bit different. This is based on an access control list or an ACL. There's a typo there. That's not link. That should be list itself. But basically, the way it works is you basically have your privileges in the access control list itself, right? So rather than actually my credential, basically having all the details about what I can access into the service, it more or less lies on the back end, right? So let's say I have Alice. I was able to read and write particular things for this key. So a little bit different. So these are basically two different models, capabilities versus ACLs, right? And revocation here is also easy because at this point I can just modify the things on the back end. I don't need to contact anyone else. Maybe a little bit easier than doing it for capabilities. I don't need to change the lock. I basically just change everything else on the back end itself. And the other thing about this too is that mutations on the ACL may not really affect any other individual as well. I can basically just add maybe read prime or something like that to Alice's thing, and then you go from there. This is also kind of a little more centralized because I have to go to that provider and actually get this information from them directly, rather than maybe just giving my API key to someone else. The other thing as well is possible to duplicate a little bit easily, and also has a little more coarse-grained access. Oh wait, that was a leftover from something else. But can be coarse-grained typically. And then it's also pretty widely used. People use this for OAuth, HTTP authentication, or whatever else. It's probably the default thing used today, typically to access the web. So I also thinking, when I'm designing these services at Lightning Labs, it's how do we have these new forms of APIs? Maybe have some of these new traits that we want in these APIs, basically make them a lot more easy for developers and allow these things to be hooked up a little more seamlessly across the web. And like I was saying, using AWS, people probably used this many times before. So we'll take a detour to macaroons. I guess some people would say those are macarons, but I'm going to throw them all in the same bucket for this. So it's basically a cryptographic bearer credential, right? And what I mean by this is basically it's a bearer credential, that key, but it uses some cryptography to basically give us authentication, also integrity, and also unforgeability, which is pretty cool. So you can actually forge one of those keys. I can go take someone else. I can maybe just copy it, and then maybe the door would accept it. In this case, it can't really be forged because you actually need this secret material in order to make the key itself. So it's basically made via this chained H-match construction, right? So typically you have a root secret key. Once I have that secret key, that's at the server. No one else can actually access that. I use that root secret key to then drive every single key down below. So this is really cool because it's actually unforgeable, like we're saying. You can't make a fake key because I, the server, have the key itself. So that means it can't be duplicated pretty easily. It's also pretty easily authenticated. So basically, the way you check it, you basically start with the root macaroon secret, then you actually hash down maybe some capabilities, maybe like Alice, read, write, or whatever else. And so it's very easily authenticated by any other individual. Once again, very easily verifiable. Another cool thing about it as well is that, like, because we have this chain HVAC construction going down, hash functions are kind of like a one-way construction. You can't really go back up, right? So like, if I give Alice like a capability to like read on Tuesdays, she can't take that and say read on Wednesdays, right? Because once again, you basically have to invert the hash function and then modify, Tuesdays to Wednesday, and then go back down and again. And the cool thing about it as well is like delegation is possible. So I can basically just give you a macaroon. You can actually then even like attenuate it, meaning you actually hash one level down. So let's say I give you something that says you can read on Tuesdays. I can then take that and you say you can read on Tuesdays at 1 p.m. Right? So I can always make it weaker. I can never make it go stronger again. So I can just like hash down as normal as the way we go. Other cool thing about this basically has a very like fine-grained authentication. So rather than like read and write, maybe I can say you can like read this particular endpoint, or maybe you can pay. You can have a maximum of like 1 million satoshis and so on, or you kind of have some like must kind of like direct way. You must do this along with their provider information. Another cool thing, you can basically also kind of like authenticate data along with the macaroon itself, which we'll be using a little bit shortly as far as the way we're going to construct this new thing that we call an LSAT. So let's just kind of like go an overview of the way things work today. Typically, APIs or API keys kind of obtained from a central source. The other thing about them is they're also typically based on kind of subscription-based billing. So maybe I have API keys in AWS. I can just keep taking it. Maybe at that point, if I forget about it, they just keep draining my bank account or my credit card or whatever else. Typically, they also obtained via credit cards, basically using the legacy rails, not like the new internet money rails, Lightning and so forth. And this is kind of like not very good because you actually kind of block a lot of portions of the population from actually using these API keys themselves, right? Now everyone has credit cards, therefore they may not be able to access all these cool resources on the internet. We basically want to make this a lot more widespread used in a lot more widespread manner. Now, typically, it's all distributed maybe via like a side channel. So rather than like me actually obtaining the API key directly through the protocol, if it's kind of a thing like that, maybe you always have some like additional kind of like thing you talk on the side. So we typically also obtain it via kind of like website or login. And another thing with this, typically, it's like dangerous to share with others because if you have the API key, you maybe like you just lose all capabilities, and at that point, someone can drain maybe like your resources, maybe like mine cryptocurrency on like your cloud account or something else like that. So the question I had is basically, can we do better? So like this kind of like I came with this idea maybe like a year or so ago, working on some new services, working on Lightning Labs, soon to be deployed. And came with this idea of basically, if the internet has some new money, why can we kind of like redesign the way we actually do API keys and make them a lot cooler, right? So now here's the new vision. Right, so basically, we want them to be decentralized by nature. Ability to basically like pass them around between other individuals, maybe even obtain from many other individuals as well. We want to kind of like have like metered billing, so it's kind of like a pay-as-you-go type of thing. Maybe I'm paying for like these credits as I go. Maybe it's like a video thing. Maybe it's like pictures. Or maybe it's even some kind of like machine learning as a service API or something like that. And also we want to also like have it be natively obtained for Lightning. So basically, we're going to swap out the old rails for the new rails. This makes it a lot more accessible. The cool thing about this is we actually have zero login required at all. There's no login. There's no credit cards. Basically, I can just access the thing directly to the API. As Rusty was saying earlier, it's kind of like just trying to take my money and do the service. And then I have this API key and I go along with that. And maybe there's something fair exchange. If you guys know kind of like how atomic swaps work, there's a little bit kind of capabilities that we use along with that too. And the other cool thing is basically have like kind of like protocol level distribution, right? So I want this all to be within protocol because I want this to be for developers. Basically, developers interact with these services, and also maybe servers interact with themselves. And maybe this protocol is maybe it's built, maybe it's HTTP, maybe it's HTTP2, or gRPC, which some of you know that LND uses. And gRPC is actually just a superset of HTTP. So gRPC uses HTTP2 as a transport, like everything else. The cool thing about this is the ability to also attend it with other individuals, right? So let's say I have like maybe like an Android phone. I have kind of like intent on Android phone, which let me pass through capabilities to other individuals. I can say, okay, hey, on my Android phone can maybe like send payments of 1 million satoshis. I can then give that to another application, maybe restrict that down. They can only send 1 satoshi every day or something like that. So I can basically have a very cool authentication model between all these different individuals in a decentralized way, because anytime you attenuate, you never need to go back to the actual provider in order to get the new key. You can just like do that yourself and actually attenuate it down and give it to another individual. And otherwise. And the other cool thing, you can actually maybe even have these be tradable with other service providers yourself, right? So let's have an API key. Let's say for some reason maybe the cost goes up, maybe it's like a little bit, it gets really hot in the future. I can actually trade I can trade these API keys with these other individuals. Once again, using kind of like an atomic swap protocol as well. So like I have like credits for like disk space. Maybe disk space gets very expensive in the future for some reason. I have the API key. I can then like sell it for a higher price in some like open market perhaps. Click. All right, cool. So now we'll get into kind of like the construction of exactly how it's working. So I'm going to focus on HTTP initially because it's a little bit simpler than maybe some HTTP or gRPC. Some people know this code called HTTP for two payment required. Basically, it's kind of like HTTP. We have like things like OK, authentication required, or maybe the server error or something like that. And more is more or less basically a way to signal that some payments are required before you are able to actually access a particular service, right? And typically, it's not mostly like unused. But I think when I saw that, I was like, okay, wow, that has to be Bitcoin. Basically, like what else are you going to be using on the internet? We're going to be doing things going forward. And here's kind of like a strawman protocol, the way it could work possibly. So first, the client issues a request. It's kind of like get some v1 the API, HTTP.1.1, and let me the host is like some cool site. I want to access what's going on. They have a cool API. Server then responds with a challenge, right? And the challenge is once again, we send back the reply is HTTP 402 payment required. So basically, it's not going to give the client the response until it actually makes its payment. And then in the header, we have this new kind of authentication method, just called LN for now. It has an invoice, right? What happens now like the client then pays the invoice and then reissues the request, attaching the the invoice along with the invoice and pre-image along with it itself. The server then checks that the pre-image matches the invoice, and then boom, it can go everything by itself. The cool thing with this is actually the server itself just needs to get an invoice from the Lightning node, but beyond that, whenever it's checking any of these responses, it can be completely like offline, or not offline, but it can be more or less stateless, right? Because it can actually verify the invoice was properly paid. It can verify that the node actually signed the invoice to create the invoice itself, and also that the pre-image was properly crafted. So what we get with this, we basically get kind of like rate limiting in a sense, because we can actually now raise the price of servers, and kind of price it depending on like what's going on. We also get some degree of super resistance as well, and just even with it, we kind of get like a degree of like login, right? I can just take that kind of like tuple of the LN invoice and also the pre-image together, and that's like now my login to any particular site. So there's no email, and maybe like I want to have some persistent session, and I can use this, I can use this purpose to actually get that. So this basically covers our payment. So we talked about we want also some capabilities, right? We want the ability to like be able to kind of like have like fine-grained access in particular services. So the question is like, how do we do that? So click. This is where LSAT comes in. So the font got a little bit smaller. This is going to be the heavy slide in the the kind of presentation. So just bear with me on this. So LSAT stands for Lightning Service Authentication Token. It's not the like law school admission test. I'm kind of co-opting that instead, and we're going to be doing something a little bit cooler. And so basically, kind of like a Lightning native, macaroon-based API credential. So once again, this is something that once you have, you can actually access the service itself. And you don't need any of the individual to maybe authorize you and to do anything else. So along with what we get before, we also get maybe some application level DOS resistance. We also get this really cool thing and kind of like fine-grained authentication as well. So we're going to go over the kind of the protocol now, kind of like top on the client server side. So basically, you can view this kind of like a superset on what I presented just a little bit earlier. Basically, how do we actually do the entire thing with the LSAT protocol? So now we have a new server response. The server response, once again, payment forward to required. But now we have a slightly different authentication headers, right? So we have LSAT before it was LN. Now we have the macaroon there. The macaroon there is basically kind of like what your capability is. We also have like an invoice once again. So like one thing to like note as well is like the macaroon is actually now like half complete. So like the LSAT in totality is actually the macaroon along with the pre-image. So what happens like now the actually server sends a half complete macaroon over to the client, and it gets completed once the client actually pays the pre-image. So this is kind of like an example. Let's say I have like some ID. We're doing loop out. This is like the first tier, and maybe I have like a max of like 1K loops using this thing, or maybe that's even like 1K stashes of that itself. One important thing to know is like now the actual macaroon commits to the payment hash, which is very important because this is another thing as far as like authentication, also enforceability. Because now and the other thing as well, like we'll also give an invoice along with it, which also commits to the payment hash and the macaroon as well, so everything is fully authenticated. Now we have the client-side macaroon completion. Basically, they pay the invoice and they actually get the pre-image. Once they have the pre-image, then they complete the macaroon. So now the macaroon is now the LSAT itself is like the macaroon and the pre-image along with it. So basically, this is like similar to the invoice thing, but now we have a lot more information in the macaroon itself that the service can actually use to dispatch any resources back to the client. And so then reaches the request, does a get with HTTP 1.1. But now we have some new headers. The new header is basically the authorization header, and we have the LSAT as kind of like the resource type or the authorization type. Now we pass in the macaroon and the pre-image together, and then boom, now we have our end-to-end macaroon itself. And the proxy, the verification is pretty simple as well. It just verifies the signature of the macaroon. So once again, the macaroon is actually unforgeable and actually ensures that this was actually crafted by the own server. No one else can actually make a fake macaroon. And then finally have the ability to just for the the proxy itself to actually verify the macaroon is actually done properly. So basically has the pre-image, make sure it matches the pre-hash, and then boom, now we have everything there. This is also cool because now the requests are authorized. It's also cool because it's actually fully stateless. So rather than like having like a new database lookup or Lightning or maybe new RPC call every single time a payment request comes in, we actually just do this once at the end, and it's pretty cool. So yeah. All right, click. Moving on. So this is what we have. We have LSAT, basically like decentralized API credentials obtained over Lightning, Lightning native using new iterated money rails. No login, no sign up. All the payments happen. Can be metered. We do a bunch of cool stuff with it. And like we're saying before, we gain a bunch of cool things for like rate limiting. We get also kind of like layer 7 application DOS resistant. This is like the OSI stack layers. So not like layer 7, some super duper Lightning. This is like the application layer. We have like the presentation session right below that. And we have some cool future extensions. One you can actually kind of like have. You can use the server itself to actually assist trading of these LSAT tokens. But you're kind of like an atomic swap. So basically, the way you do this, you have your regular LSAT token, then you have a new LSAT token, which commits to the prior one, and then now has 2 payment hashes. One of them from the server is normal, and another one from the actual participant. So when I pay you for this thing, then I actually complete the new LSAT token itself. This is how we can do atomic swap of these kind of like API keys or credentials, which is pretty cool. Maybe some implications as far as like trading API keys of something like trustless market. Like I was saying before, and then deployment-wise, so we're actually going to be rolling this out pretty soon to the Loop river, coming near you, where we have to do this to kind of like have different capabilities on the end clients. Maybe we have different fee tiers. Maybe we have different capabilities. We can also use maybe roll out some kind of like new features as far as like A/B testing on the side as well too. And this is going to be probably like default authentication method in any like thing that we make as Lightning Labs. We have some other things coming out too pretty soon. And we have this like demo right here. So like if you guys remember some of these, some of the HTTP requests I actually did, you can type those in manually. I mean, if you're like want to be hardcore, you can use like curl or something like that and hit this. this site right here. Basically, this is a site where we actually have some information about like what kind of like good nodes or what we think are good nodes in network, something we've been working on for a while, code name kind of like a bot score thing. And we also have some other things coming along as far as like specification, client-side library, and also for HTTP2 support. So in this talk, I described mostly HTTP support, but HTTP2 is basically a similar thing. We're actually going to use the exact same headers, which is a slightly different format. Then we also have gRPC on top of that, which is also ability to actually have a gRPC service that speaks LSAT natively. We have these things called a client interceptor, which basically is a way you can kind of intercept a request or response on the client or the server side. So it'd be very easy to kind of like plug it into your own service and maybe to basically have this new, kind of like payment-aware reverse proxy for any of the servers that you have coming out. And yeah, that's it. Any questions? Thing is, like, I have a lot of time left, so if you guys have questions, I have 15 minutes. I can just chill up here otherwise. I guess I have 30 total, but yeah. I think there's one here too.
Hey, just wondering about these, the LSAT, would they be able to support something like a streaming service or something like that, where, I don't know, like, how exactly would that work?
Yeah, so I mean, so like, you can support a streaming service via your kind of like gRPC, because every single request and response can also carry a new challenge header as well. So I can do like, request. You give me a response, okay, forward to required. You basically need, for the next 20 minutes of the video, that's into your new LSAT token. We keep going from there. So you can actually you can do the streaming. You can actually do the authentication kind of like bidirectionally in kind of a gRPC stream. Or even HTTP2 kind of check encoding or kind of like things like that.
Yeah, that's kind of what I was thinking of. But I was also wondering how that would affect like performance, because Macaroon has the signature requirement. So like a lot of streaming apps and stuff like that have a lot of latency requirements.
Oh, definitely. Yeah, I mean, so like one thing is like they call it a signature, but it's really just kind of like symmetric crypto. So you're just hashing the entire time. Hashing is pretty simple. It's pretty easy to parallelize, and also we have like really good optimizations for like assembly and things like that. So it's not really a digital signature. It's all symmetric crypto, so makes it pretty quick.
Okay.
Yep. Last question over there.
Yeah, you say it's decentralized by nature, but an API provider can deny service to a given macaron, right?
Sorry, can you repeat the first part?
The API provider can deny service based on the macaron, right?
Sure.
Yeah, can't you use like something like ring signatures to avoid the API providers to deny service to a given macarons without denying service to all the IP credential bearer? Or something like that.
Okay, you're saying like you want to reveal that like my identity in the macaroon itself. You want to use ring
No,
signature?
no. I mean, I can deny you providing the service based on the macaron, right?
Because I can identify it from the payment, is what you mean?
Yeah, or based. I mean, you sign the macaron, right? So you can.
The client doesn't. The client never signs
The
anything.
server.
The server does, yes.
Yeah, the server does.
Indirectly.
Yeah, can you use like ring signatures or something like that to avoid?
Possibly. I guess it depends. Like they can always kind of like deny you access because it's like there is a particular service. I guess you could get some anonymity as far as like being able to not tell which macaroon I have here. But yeah. So I guess every individual got together and kind of like had ring signature over all the macaroons. Maybe there's some like Merkle tree on the server side as far as like all the possible macaroons or that be created. Then something like that would be possible. So you'd be able to say, okay, I have one of these N LSAT tokens. I don't reveal basically who I am. Maybe when I paid for it, but then I can actually have that to the server. Maybe a little more anonymity in the service. Yeah, it can also be over Tor as well, so you don't really reveal the location. It could be over many other transfers as well too. So, yeah.
How do you track timeouts like this macaroon is valid for 20 minutes kind of thing?
Good
Especially
question.
with caching, because this caching is supposed
yeah.
to be stateless. So how does it know that this thing is already being used? Or?
Yeah, good question. So basically, like you can add that as like a caveat on the macaroon itself. So basically, you can basically have like an expiration time or like some like deadline as well. So and because the other thing as well, like the client can't mutate that once again because it actually has the full HMAC chain. So this is like I can give you macaroon. This is okay. This expires in 1 day. So then 1 day you must actually look this up. And the other cool as well is like because we push much of the storage of the LSAT token of the macaroon to the client side, the server side implementation is a lot simpler. There's a lot less state, right? Because you're basically giving me what I can verify LSC for the macaroon itself. I can look up the time and say, okay, boom, this expired, reject, and then you have to like buy another one, possibly.
Okay, but I can't get a macaroon that says like 1 hour worth of video to be spent whenever I feel like it. that would be tricky.
Well, so yes, so you can as well. So there's another more I didn't really talk about. It's kind of like a per request discharge in a sense. So basically, like let's say like you buy like the first 5 minutes. Basically, you have 1 hour left. I give you a new macaroon and say, okay, you have 55 minutes left, right? You keep going from that, and then so now at that point, I basically need kind of like some simple revocation state on the server side, similar to kind of like rig signatures for like the key image. Then at that point, I can basically I can ensure that I can once again push the storage requirement over to you, but then always have this macaroon that can itself be kind of like metered in a sense. So either I store that on the server side as far as like the amount of time left for that particular ID, or I basically put that onto the client side, which is a little bit better solution in my opinion, because then make things a lot easier and it's mostly stateless at that point.
Thanks a lot. My question is, are you going to provide some more centralized way to store and manage macaroons, not just like files, maybe some in database or some secret storage like that? Thank you.
Yeah, definitely. Like there's like super old, like, I think issue in LND called like to make like a macaroon pouch or like a cookie jar. So basically you have this kind of maybe like kind of like a client-side encrypted database that you actually store your macaroons in, because there are capabilities after all. Because the capabilities if you have access to, you can use it immediately. So basically, yeah, we could have some additional kind of like storage system on the client side for these things, because they are kind of like sensitive cryptographic material as well. So
Thanks.
yeah, no problem.
So I've heard a lot of talks about extensions this morning.
Extensions?
Yeah, extensions on Lightning.
Yep.
What are they? What is the scope that they provide? And on an implementation level, what happens like if one node supports an extension and another node doesn't? Like a relay supports and you don't, for example. Like, I guess elaborate on what they are, please.
Okay, yeah, I mean, so basically there's a few formats. Like one is kind of like what we have like is feature bits, basically whatever different peers connect, or even like an announcement, you basically have kind of like a bit field, basically net bit field signifies a particular feature understanding on your end, right? So if I connect to you, we both have the same feature, that means we can actually use this new protocol, aside from the specification itself. So this is really cool because it basically lets kind of like more rapid experimentation between the end nodes. One other thing that we have as well is like in Lightning, there's kind of like a requirement that every single message can be padded up to basically 65 kilobytes. So anything that at the end that you don't understand, you can basically just ignore, right? So what we can do now, let's say like we both integrated a new feature, I can then now add this new feature or new even fields at the end of an existing message in a way that we don't really need to kind of break anything else, because typically old clients should basically ignore that data. So it's also like forwards and backwards compatible as well, which is pretty cool.
Do you think these could be used to track an identity across multiple services?
Mm-hmm.
And do you see any privacy implications of that, similar to how on the web today, your cookies can be used to track and profile across sort of multiple services to be able to tie together an identity?
Yeah, it's a good question. So there's no requirement that user actually uses the exact same LSAT for their entire lifetime. They can get them as they go, right? So every single new site, they can actually get a new LSAT. They can also even have several different LSATs per particular site, just to maybe even like increase their anonymity set as well. We also have the idea from Antoine over there about maybe having some sort of like signature protocol on top of it as well, for you to have more anonymity. But yeah, so there's no requirement that you have like one login. I can always be Bob12, Bob3, Bob4 as I want. So yeah. So it's a lot better for tracking at that point, because you can basically opt out to it. Opt out of it, rather.
It seems to me that the sum of, like, the sum of a bunch of attenuated macaroons, the value of that could be larger than the parent macaroon, meaning like if I was AWS, I could be like, I'm gonna sell, space or processing power for like the entire year, and then I'm gonna interface with somebody who can then resell that to other people. Do you see that being a potential that, the individual macaroons, like once the market actually like prices those, that they'll be a higher value than the parent macaroon?
Possibly, yeah. And I guess like the thing there is just like basically like it's tradable as long as the actual provider allows it to be tradable, because like the protocol I have in mind for tradability actually requires some interaction on behalf of the provider. So they could kind of like possibly clamp down on the market if they wanted to, just because actually providing it at the end. But that could be the case where it's like maybe like a year is like too big an advance. You kind of like chop out a contract into smaller bits. So basically here's like a 1-day contract or 2-day contract, which is maybe more talking like 1 year, because I don't need 1 year of disk space. I'm gonna like some quick demo to hack day. I only want like 30 seconds of like CPU or something like that. So it's definitely a possibility. All right, Denzo? All right, cool. Y'all have 6 extra minutes then.
Yeah, thank you,
No problem.
Olaoluwa.
Thank you, Olaoluwa.